We are going to study equilibrium in a solution on 28th April 2019. 1. Ionization of a weak acid. A weak acid is the one that partially ionizes in aqueous solution to give hydrogen ions as the only positively charged ion. Consider a weak acid, Ha. In a solution, it ionizes as follows. Acid plus water, you get hydrated hydrogen ions plus negative ions. Kc will be equal to concentration of hydrated hydrogen ions times the concentration of negative ions over the concentration of the acid times the concentration of water. But the concentration of water is almost constant. So it can be incorporated into Kc, that Kc times the concentration of water is given another constant Ka, which is equal to concentration of hydrogen ions into concentration of negatively charged ions over the concentration of the acid. Usually, the concentration of hydrogen ions is expressed as pH, where pH is equal to negative log hydrogen ion concentration. Implication of Ka: the higher the Ka, the stronger the acid. The higher the Ka is, the higher the concentration of hydrogen ions in a solution, the stronger the acid. Example 1, the pH of 0.1 mole ethanoic acid is 3.4 at 25 degrees Celsius. Calculate Ka for the acid. So we will first write the equation. Ethanoic acid ionizes to form ethanoate ions plus hydrogen ions. Initially, they have told us that the concentration of the acid is 0.1 molar. There is no ethanoate ions, there are no hydrogen ions. At equilibrium, they have told us that the pH of the solution is 3.4, but pH is equal to negative log hydrogen ions. It implies that hydrogen ions is equal to 10 to the power negative pH is equal to 10 to the power negative 3.4, which is equal to 4 times 10 to the power negative 4. We antilog this value, we get 4 times 10 to the power negative 4. It means that at equilibrium, hydrogen ion concentration is equal to 4 times 10 to the power negative 4. But when 1 mole ionizes, you form 1 mole of ethanoate ion and 1 mole of hydrogen ions. So the concentration of ethanoate ion will be equal to 4 times 10 to the power negative 4. And the concentration of the acid at equilibrium will be equal to 0.1 minus 4 times 10 to the power negative 4, which is equal to 0.0996, which is approximately equal to 0.1. But Ka is equal to concentration of ethanoate ions into concentration of hydrogen ions over the concentration of the acid, which is H3COOH. So it will be equal to 4 times 10 to the power negative 4 into 4 times 10 to the power negative 4 over concentration of the acid, which is 0.1. This will be equal to 1.6 times 10 to the power negative 6. moles per decimeter cubed. So the moles per decimeter will cancel with this one, remain with moles per decimeter cubed. Example 2, RCO2H is a weak acid. A, write equation for the ionization of the acid in water. So the acid will ionize to get the acid anions plus hydrogen anion. Then B, write expression for ionization constant Ka for the acid. Then you can see that Ka is equal to concentration of the anion RCOO into the concentration of hydrogen ions over the concentration of the acid, which is moles per decimeter cubed. So the moles per decimeter cubed over moles per decimeter cubed cancel. We remain with moles per decimeter cubed. Calculate pH. We first write the equation RCO2H ionizes form RCO2 minus plus H plus. We can say initially they have told us we have 0.25 moles of the acid. We don't have moles of the solid ions and the moles of hydrogen ions. At equilibrium, we can let the concentration of hydrogen ion to be equal to X, the concentration of the solid ion to be equal to X, then the concentration of the acid, because 1 mole is ionized to give 1 mole. If X moles form, then X moles of the acid have ionized, and we are remaining with 0.25 minus X. Applying Ka, we can say that 1.8 times 10 to the power negative 5 will be equal to X squared over 0.25 minus X. We can use quadratic equation method to get the value of X, but we can also avoid the quadratic equation by assuming that X is very small, that 0.25 minus X is approximately equal to 0.25 moles. Thus, 1.8 times 10 to the power negative 5 will be equal to X squared over 0.025. X is equal to 2.12 times 10 to the power negative 3, and this X is the same as the hydrogen ion concentration. Therefore, pH is equal to negative log hydrogen ion concentration is equal to negative log 2.12 times 10 to the power negative 3, which is equal to 2.67 or 2.6. In the logs, we don't round off, we just truncate. Okita bosa science, kwano kwa beti science, dafu ya bosa science, truth na beta, truth na omega, truth na alpha science. Example 3. Calculate the hydrogen ion concentration and the pH of 0.01 molar ethanoic acid solution. Ka is 1.8 times 10 to the power negative 5. Ethanoic acid ionizes to give ethanoate ion and the hydrogen ions. So that telling us that initially we have 0.01. We have no moles of hydrogen ions, we have no moles of ethanoate ions. At equilibrium, assuming the concentration of hydrogen ions is X, the concentration of hydrogen ions is equal to the concentration of ethanoate ion, is X. The concentration of ethanoic acid will be equal to 0.01 minus X. So Ka Ka will be equal to concentration of ethanol weight ions into the concentration of hydrogen ions over the concentration of ethanoic acid. But Ka is given is equal to 1.8 times 10 to the power negative 5 will be equals to X times X, concentration of hydrogen times the concentration of ethanoic ion, over the concentration of the acid, which is 0.01 minus X. But X is very small, that 0.01 minus X is approximately equal to 0.01. It implies that 1.8 times 10 to the power negative 5 will be equal to X squared over 0.01, and X, which is equal to concentration of hydrogen ions, will be equal to root 0.01 times 1.8 times 10 to the power negative 5, which is equal to 4.2 times 10 to the power negative 4. Therefore, the concentration of hydrogen ions is equal to 4.2 times 10 to the power negative 4 moles per decimeter cubed. pH is equal to negative log hydrogen ion concentration, which is equal to negative log into 4.2 times 10 to the power negative 4. So when we apply log answer, we get 3.3.
The Science Foundation College e Namave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding eri abawala n'abalenzi. Ku O-level tusomesa arts ne sciences, ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
2. Ionization of a weak base. A weak base is a substance that hydrolyzes in water to produce hydroxide ions as the only negative ions in a solution. For instance, base B plus water will give this ion plus hydroxide ions. Kb is equal to concentration of base ions times the concentration of hydroxide ions over concentration of the base. Kb is a function of temperature, and the higher the Kb, the stronger the base, or the more hydroxide ions are produced in the solution. Example 4, calculate the concentration of hydroxide ions in 0.1 molar ammonia solution. Ka is equal to 1.8 times 10 to the power negative 5. You can see that let the concentration of hydroxide ions equal to X. So ammonia hydrolyzes in water hydroxide ions. Initially, we have 0.1. We have no moles of hydroxide ions. We have no moles of ammonium ion. At equilibrium, we have said the concentration of hydroxide ion is X is equal to concentration of ammonium ion X. The concentration of the ammonia will be equal to 0.1 minus X, but X is very small, that 0.1 minus x is approximately equal to 0.1. Kb is equal to concentration of ammonium ion into concentration of hydroxide ion over the concentration of ammonia. It implies that 1.8 times 10 to the power negative 5 is equal to x squared over 0.1, because we said that 0.1 minus x is approximately equal to 0.1 over 0.1. Therefore, x, the concentration of hydroxide ions, will be equal to root 1.8 times 10 to the power negative 6, which is equal to 1.34 moles per decimeters cubed. Ionization of water. Water ionizes to form hydrogen ions, aqueous, plus OH, aqueous ions. The ionization constant of water, Kw, will be equal to concentration of hydrogen ions times the concentration of hydroxyl ions. At 25 degrees Celsius, Kw is equal to 10 to the power negative 14, which implies that at 25 degrees Celsius, the concentration of hydrogen ions will be equal to Kw over the concentration of hydroxyl ion is equal to 10 to the power negative 14 over concentration of hydroxyl ion. This expression helps to calculate the pH of bases. So we can use this expression to calculate the pH of bases in aqueous solution. Example 5. Calculate the pH of 0.1 molar ammonia solution. Kb is 1.6 times 10 to the power negative 5 moles per decimeter. W is equal to 10 to the power negative 14 moles squared per decimeter to the power negative 6. So what do we do? First, we write an equation for ionization of ammonia in water, which is equal to ammonia plus water. You get ammonium ion plus hydroxyl ion. Initially, they have told us the concentration of ammonia is 0.1. At equilibrium, supposing the concentration of hydroxide ion is X, the concentration of ammonium ion is equal to the concentration of hydroxide ion will be equal to X. When X moles form of hydroxide ions, X moles of ammonia have reacted with water. Therefore, the moles of ammonia remaining will be 0.1 minus X. But X is very small. 0.1 minus X is approximately equal to 0.1. From Kb is equal to concentration of ammonium ion into concentration of hydroxyl ion over concentration of ammonia it implies that 1.6 times 10 to the power negative 5 will be equal to x squared over the moles of ammonia, which is 0.1, and x will be equal to root 1.6 times 10 to the power negative 5 times 0.1, which will be equal to root 1.6 exponent negative 5 times 0.1 close bracket, which is equal to 1.27 moles, which is equal to 1.27 times 10 to the power negative 3 moles per decimeter, and this is the same as hydroxide iron. X was hydroxide iron, but we want the pH. To get the pH, we must get the concentration of hydrogen ions. Concentration of hydrogen ions, which is equal to Kw over concentration of OH ion, which is equal to 10 to the power negative 14 over 1.27 times 10 to the power negative 3. Which is equal to 7.9 times 10 to the power negative 12. But pH is equal to negative log hydrogen ion concentration, which will be equal to negative log answer, which is equal to 11.1. So if you calculate the pH of a base and is less than 7, just know that your answer is wrong. Bases have got pHs higher than 7. Example 6. Calculate the pH of 0.5 molar sodium hydroxide ion, sodium hydroxide solution. Kw is equal to 10 to the power negative 14 moles per decimeter cubed. What do we know about sodium hydroxide? Sodium hydroxide is a strong base. Therefore, ionizes completely, not reversibly, in water to form sodium ions, aqueous, plus hydroxide ions, aqueous. So the concentration of sodium hydroxide, since it ionizes completely, will be the concentration of sodium ions, will be the concentration of hydroxide ions. Again, the concentration of hydrogen ions is equal to Kw over the concentration of hydroxide ion, which is equal to 10 to the power negative 14 over 0.05, which is equal to exponent negative 14 divided by 0.05, which is equal to 2 times 10 to the power negative 13. But the pH is equal to negative log hydrogen ion concentration, which is equal to negative log 2.2 times 10 to the power negative 13, which is equal to negative log answer, which is equal to 12.6. Example 7. A solution containing 2.3 times 10 to the power negative 10 moles per decimeter of aluminium hydroxide completely ionizes in water. Calculate the pH of the solution. First, write an equation for ionization of aluminium hydroxide. They have told us completely, so we use a single arrow to form aluminium ions, aqueous plus free hydroxyl ions. They have told us the concentration of aluminium hydroxide is 2.3 times 10 to the power negative 6. But one mole will give you 3 moles of hydroxide ions, so the moles of hydroxide ions will be 3 times 2.3 times 10 to the power negative 6, which is equal to 6.9 times 10 to the power negative 6 moles per decimeter cube. But they have told us to calculate pH. Before we get the pH, we must get the moles of hydrogen ions, which is equal to 10 to the power negative 14 kW over the moles of hydroxyl ions, which is 6.9 times 10 to the power negative 6, which is equal to, we calculate, pick your calculator, we get exponent negative 14 divided by 6.9 exponent negative 6 is equal to 1.45 times 10 to the power negative 8. Then pH is equal to negative log hydrogen ion concentration is equal to negative log 1.45 times 10 to the power negative 8, which is equal to 8.8. We say that whenever we get the pH of a base, it must be greater than 7. Example 8, a 0.01 molar solution of ammonia a 0.01 molar solution of ammonia is 4% ionized. Then calculate pH. 2. Calculate the base constant. Ammonia plus water partially ionizes to form ammonium ions plus OH minus. The concentration of OH will be equal to the percentage ionization 4 over 100 times the concentration of ammonia, which is 0.01, which will be equal to 4 times 10 to the power negative 4 moles per decimeter cubed. Hydrogen ion concentration is equal to Kw over hydroxide ion concentration, which will be equal to 10 to the power negative 14 over 4 times 10 to the power negative 4, which is equal to 2.5 times 10 to the power negative 11. pH is equal to negative log hydrogen ion concentration is equal to negative log 2.5 times 10 to the power negative 11, which is equal to 10.6. Part 2, Kb is equal to concentration of ammonium ion times the concentration of hydroxide ion over the concentration of ammonia, which will be equal to the moles of hydroxide ions are equal to the moles of ammonium ion, which is equal to 4 times 10 to the power negative 4 squared over the concentration of ammonium solution, which is 0.01, and this one is equal to 1.6 times 10 to the power negative 5. Thank you very much. In the next lesson, we are going to discuss buffer solutions.